Good morning, all of you.
Good morning,
Good
sir.
morning, sir.
Good morning, sir.
So in last class, we discussed logarithmic inequalities. To solve the logarithmic inequalities, we need some important points. They are, first one is logarithmic function is increasing when the base is greater than 1 and is decreasing when the base is less than 1. And increasing means whatever the relation between the x values, the same relation holds between functional value. Functional value means when you apply logarithm on both sides, whatever the relation between the x values previously, after applying logarithm, the same relation holds. That is called increasing. Decreasing, opposite. And coming to graph of the logarithmic function, it is log x to the base c, natural logarithm. I already told you log x to the base a is an increasing function when a greater than. Here we are taking e. E is always more than 1 because it lies between 2 and 3. So that's why the graph of log x to the base a is increasing. And we know log x to the base a is defined only when x is positive. That's why we have the graph right side of y-axis one, because x is positive in the right side of y-axis. And generally, to draw the graph of any function, we take x values on x-axis, log x values are on y-axis, and its domain is only positive real number, that is greater than 0. That's why as x value tends to 0, x is not 0, log 0 is also not defined. X value tends to 0 means it is very close to 0, like 0.000001. Log x value tends to minus infinity. And as x tending to infinity, log x also tends to infinity because it is increasing function. X value increases, log x values also increases. So that's why it start here. It's very close to y-axis, doesn't meet the y-axis and is increasing in this way. And at x is equal to 1, no, its corresponding logarithmic value is 0. That's it meets the x-axis at x is equal to 1. So this is the graph of log x to the base e. As x value close to 0, log x value tends to minus infinity. So you can write here like this. First, domain of log x to the base c. Already we discussed what is the domain is. The set of x values that defines the function. Here log x to the base c is defined when x is greater than 0. That's why the domain is 0 to infinity, open 0 to infinity. And the range, log x value positive only, log x is defined. But log x value may be negative. Observe that graph of logarithmic function. We have graph below x-axis as well as above x-axis. Above x-axis, y positive. Y means log x to the base c. Below x-axis, it is negative. That's why log x to the base c values varies from minus infinity to infinity. So range is R, but domain is 0 to infinity. And clearly from the diagram, as x tends to 0, log x to the base c tends to minus infinity. And as x tending to infinity, log x to the base c also tends to infinity. So x values are increasing from 0 to infinity. Log x values are increasing from minus infinity to infinity. That's why log x to the base is an increasing function. Because base, that is e, that is more than 1. So note on the graph of logarithmic function. Now write down the problems on logarithmic inequalities.
1 minute, sir.
Sir, one.
Okay, na?
Yes, sir.
Yes. Okay, sir.
Yes, sir. You can scroll down.
Wait, sir, I'm writing.
నా చార్జర్ తేయాలమ్మా. అమ్మా
Write down the question.
గట్టిగా వచ్చినా కూడా
Solve the following inequalities. First question. Log x2 base 1 by 2 greater than or equal to 0. Log x2 base 1 by 2 greater than or equal to 0. This is the function. Log x2 base 1 by 2 greater than or equal to 0. Listen. Already in last class we discussed this thing. Log x to the base a is equal to y, x is a power y. This definition. Similarly, log x to the base a greater than y, then x is greater than a power y. When if a is greater than 1. That means increasing. If logarithmic function is increasing, if you take this a that side, same inequality hold. If it is decreasing, we get opposite. So using this fact, solve this inequality. It's a very simple question. So tell me what we have. Given log x to base 1 by 2 greater than or equal to 0. Since base is less than 1,
Sign will change.
decreasing. That's why what we have is x less than or equal to 1 by 2
1 by
power
2.
0. This is x, this is a, this is y. So x less than or equal to a power y, because base is less than 1. From this we get x less than or equal to 1. 1 by 2 whole power 0 is 1 only. And listen one thing. If you solve this inequality log x to the base 1 by 2 greater than or equal to 0, we get x values which are less than or equal to 1, less than or equal to 1. That means minus infinity to closed 1. In solving logarithmic equations, there I said one thing, that is, solution of a logarithmic equation or inequation also defines the logarithmic functions given in the equation. What are logarithmic function given here? Log x to base 1 by 2. You know, log x to base 1 by 2 is defined if x is greater than 0. Log x to base a is defined if x greater than 0, a greater than 0, a not equal to. But in this example, base is a fixed number. So obviously it satisfies this condition, second condition. Here is the variable we have. That's why this must satisfy the condition x greater than 0. Then only log x to the base a is defined. So now to define log x to base 1 by 2, you must have x values 0 to infinity. And after solving this inequality, you get x values which are less than or equal to 1. Now tell me, what is the common x values? That is the solution set.
1.
2.
What are common x values? See here, this is a real line.
0 to 1.
0 and 1.
0 to 1.
Very good. This is the real line. Here we have 0, here we have 1. This inequality says that all x values are less than 1. That is this range. This inequality says that all x values are greater than 0. That is this. So what is the common portion? This is the common portion.
0 and 1.
Don't say 0 and 1. 0 to 1. 1 closed, 0 open. Here no equality sign. Here we have equality sign. That's why. Don't say 0 and 1. 0 and 1 only integers.
Okay, sir.
Between 0 and 1 also we have a solution. So finally, what is the solution set? Open 0 to close 1. Whenever you have a doubt in writing the intersection, better you take the x values in the real line and check like this. Take a real line. Whatever real values you have, put them on in the ascending order. Then check. Here the x values are all less than 1. Here the x values are all greater than 0. We want common portion. Both are there in this interval. That's it, 0 to 1. And after writing 0 to 1, closed bracket or open bracket, that is very careful.
Inequality is
Okay, na? Write on the solution.
Done, sir.
Timetable computer.
Coming to second one. Log of x minus 1 to the base 1 by 2 less than log of x minus 1 to the base 1 by 4. Log of x minus 1 to the base 1 by 2 less than log of x minus 1 to the base 1 by 4. To eliminate logarithmic functions on both sides, to find x value, first of all, the base of both sides must be same. There is less than 1 or more than 1, not matter. But that must be equal. Left hand side base is 1 by 2. Right hand side base is 1 by 4. That's why to get right hand side also base 1 by 2. So I'm going to write the given inequality like this. You can write 1 by 4 as
1 by 2 the whole square.
whole square. Very good.
Four.
And apply the property, that is log
Two.
x to base a power m is 1 by m into
Log
x
x
to the
power
base
a.
1 by m into log x to the base a. So using that, what we have is log of x minus 1 to the base 1 by 2 is less than 1 by 2 into log of x minus 1 to the base 1 by 2. First write 1 by 4 as 1 by 2 whole square. Then use the property log x to base a power m is log 1 by m into log x to base. Now, bring this 1 by 2 inside the logarithmic function. To remove logarithm on both sides, this must be in this form. Same base and no multiples here and here. Then you can write x less than y or x greater than y, according as a is greater than 1 or less than 1. So that's why I'm going to take this 1 by 2 inside the logarithm using the property m log x to the base a is log x power m to the base a. So take this 1 by 2 inside, it will be the power to x minus 1. So log of x minus 1 to the base 1 by 2 less than log of x minus 1 power 1 by 2 to the base 1 by 2. Now, both sides we have the same base and no multiples. So now we can replace logarithms. For that, same inequality or opposite inequality decided by the base. Here base is less than 1. Na? That's why we have x
Opposite
minus 1
inequality.
greater than x minus 1 power 1 by 2. Any doubt in writing like this?
No, sir.
Because base is less than 1, logarithmic function is a decreasing function. That's why inequality sign changes after removing logarithm. In applying logarithm, removing logarithm, inequality sign changes, base is less than 1. No change in the inequality, base is more than 1. Now square it on both sides. Why squaring?
To remove
Because
1 by
right
2.
hand
To
side we
remove the
have x
square.
minus 1 power 1 by 2 is there. That's why. Now, simplify this. X square minus 2x plus 1 minus x plus 1 greater than 0. Now we get a quadratic inequality. X square minus 3x plus 2 greater than 0. This you have to solve using wavy curve. For that, what we have to do? Factorize this quadratic into two linear factors. Whenever you have a algebraic inequality is there, Here given question is a logarithmic inequality. After simplification, it will become an algebraic inequality. Now solving this using wavy curve. For that, first you have to factorize the quadratic into linear factors. Next, to make x quotient positive in each linear factor. Already it is positive. What are x values and equate each linear factor to 0?
1 and 2.
1
1
and 2.
and 2. So start from extreme right with the plus sign and move towards left with alternate.
Alternative signs.
So
Here we want the expression to be positive. So where positive
So-
sign is there?
minus infinity to 1 and 2 to infinity.
Very good. So x belongs to minus infinity to 1. Is it closed or open?
Open, sir.
Open, sir.
Open, sir.
Because no equality sign here. If you have greater than or equal to 0 is there, then you have to write a closed.
Close the bracket.
And don't take it, this is the solution set. This is the solution obtained solving this. But to define logarithmic functions in the equation, what are logarithmic functions in the equations we have? Log of x minus 1 to base 1 by 2 and log of x minus 1 to base 1 by 4. These two are defined when they are defined. If x minus a greater than, this is our x here. Log x defined x positive. Here you don't worry about the base because the base is a fixed number. Already it is positive one. So x minus 1 greater than 0 means x belongs x greater than 1. Greater than 1 means 1 to infinity. Now tell me the common values of 1 and 2. From 1 and 2. Now tell me the common values. Common values means that satisfies 1 as well as 2.
1 to infinity.
1 to 2 not there here.
No, sir, 1 and infinity only.
There are no common factors.
No
yeah.
common
Factors.
factor.
Okay.
Common values. See here. What are real numbers that are there in this interval and in this interval? 1, 2. What first inequality says? The x values which are less than 1, greater than 2. First inequality says the x values are less than 1 and greater than 2. This is the region. Second inequality says all x values are greater than 1. This is the common values, no?
2 to infinity.
2 to infinity it would be.
2 to infinity.
2 to infinity.
Open 2 to infinity. Whatever x values you collect, they must be in both the intervals. If you write 1 to infinity, 1 to 2, they're here, but not here. That's why this is not the case. If you take minus infinity to 1, that was there here, but not here. That's why that is not the common value. And 2 to infinity, that are there in this one as well as in. So better you take a real line and then check the common values for sure. So to solve logarithm inequalities, we need wavy curve also. Whenever you talk about inequalities, you require wavy curve. No doubt.
Sir, can you scroll down?
Right, one more. Log of x square minus 2x to the base 1 by 3 greater than log of 2x minus 3 to the base 1 by 3. Log of x square minus 2x to the base 1 by 3 greater than log of 2x minus 3 to the base 1 by 3.
Sir, here
First
can we
two.
directly take x square minus 2x is greater than 2x minus 3?
It
No,
would
no.
be lesser than.
Lesser
Base
than.
1 by 3, na? So since base is less than 1, it is decreasing function. That's why when you eliminate log on both sides, inequality sign changes. So this can be written as x square minus 2x less
Less
than 2x minus
2x minus 3.
What is the reason? Since log x to the base a is a
Is
decreasing function, if 0 less than a less than. For decreasing function, whatever the relation between the x values, opposite relation holds between logarithmic values. And now solve this inequality. Again, you get an algebraic inequality.
X4 minus 4x plus 3.
Amma?
X minus 3 into x minus 1 is less than 0.
X.
Okay. Tell me
So,
the x values using wavy curve.
x belongs to 1 comma 3. Open.
Open or closed?
Open.
Open bracket.
Very good. So one part completed.
Sir, X belongs to 1 comma 3.
This is the real line. We have two real numbers 1 and 3 in ascending order. This is the order. Plus, minus, plus. We need expression to be negative. That was there between 1 and 3. That's what is x belongs to 1 comma 3. And this is not the solution finally. And now log of x square minus 2x to the base 1 by 3. When it is defined?
When x square minus 2x is greater than 0.
Hmm.
And when 2x minus 3 is also greater than 0.
First
Common
solve this
value
and
is
get x
50.
value. First solve this x square minus 2x greater than 0 and solve it and get x values. This is factorized in true linear factors. That is x into x minus 2. Whenever we have a quadratic is there, immediately we have to factorize that into linear and apply waving. What are x values you got here? 0 and 2. For this linear factor, the x value is 0. For this linear factor, x value 2. Start from extreme right with the plus sign and move towards left with
So
alternate.
2 to infinity minus infinity to 0.
So x belongs to minus
to
infinity to
Infinity
0,
to 0.
and 2 to
2 to
infinity.
infinity.
2 to infinity. Take it as 2. Next, one more logarithmic function is there. What is that?
Common values we have to check.
2x minus 3. Not completed.
Acha, okay, sir.
Actually, in the given inequality, you have two logarithmic functions. For first to define, these are x values. Now, take this also. Another logarithmic function given. When it is defined, if
Well,
2x minus
the
3 greater than
Greater
2x
than
minus 3 greater than 0.
x belongs to 3 by 2 to infinity.
X greater than 3. It is a linear inequality. Directly write x greater than 3 by 2.
3 by 2.
That means x belongs to open 3 by 2 to infinity. Now we get 3 intervals. You have to find out the common values. So for that, take a real line. Tell me
2
the
to
real numbers that are there in all the 3 inequalities.
0, 2 and 3 by 2.
1, 3, 0, 2, 3 by 2. Which is
Ah.
least among all that?
3, 0.
0.
0.
0, sir.
Next, 1.
1, then 3 by 2.
Next, 3 by 2.
2.
Next, 2. Next, 3.
Okay.
Whatever the inequalities you get after solving all the cases, take the real numbers that we're having in a real line in ascending order. Now, coming to the first inequality, what it gives is x values lies between 1 to 3.
3.
1 to
This is
3.
the portion. Second inequality, less than 0, greater
Okay.
than 2. This portion. Third inequality,
3 by 2 to infinity.
3 by 2 to infinity. Now tell me the common values. All the 3.
2
Where
to
is
infinity.
that?
2 to infinity and 3 by 2 to infinity.
Wait, Ray, all 3 I'm asking.
2 to
2
infinity.
to infinity, this was not there, na? Here one more inequality is there, this one.
1 to infinity.
1 to 3.
1 to 3.
Now tell me, common value. Common values means all the 3 must exist.
2 to
2 to 3.
2 to 3.
2 to 3.
2
2
to
to
3.
3.
Very good.
2
All
to
3.
3.
This portion contains all the 3. 2 to 3. Now tell me open, closed.
Close.
Open,
Open, sir. Open.
Open.
Open 2 comma. Open 2 comma 3.
From 1 to 3, solution set is open 2 to open 3. Intersection is very, very important. Solving the inequalities is a little bit difficult, but writing the common values, that is very, very important. Now write down.
ಸ್ವಲ್ಪ ಸರ್ ಅದ
Sir, can you scroll it down?
So can you scroll down?
Sir, can you scroll down?
Write one more. Log of x minus 2 to the base 1 minus x greater than or equal to minus 1. Log of x minus 2 to the base 1 minus x greater than or equal to minus 1. Tell me what we have to do for this. Right hand side, we don't have a logarithmic function. So it is just like log x to the base a greater than minus 1. You can write this as x greater than a power minus 1 if base is more than 1. And is a less than a power, x less than a power minus 1 if a lies between 0 to 1. But here that a is also the variable. Previous cases, in the last 3 problems, base is not a variable. But here base is also a variable. That's why we have to consider 2 different cases. One is, first tell me when this logarithmic function is defined. That is log of x minus 2 to 1 minus x. Only the function. I'm not talking about the total inequality. When log x to the base a is defined,
If
When
x is
the-
greater
When if x is greater than 1,
is,
x minus 2 greater than
0 but not equal to 1.
and 1 minus x greater than 0,
not
1
equal.
minus x not equal to
Not
1.
equal to 1.
Under these conditions only, log of x minus 2 to the base 1 minus x is defined. That means x minus 2 greater than 0 means x greater than 2. And 1 minus x greater than 0 means x less than 1.
Yes, that one.
Is it right?
Yes.
X less than 1 and x is different from 0. 1 minus x equal to 1 only when x is 0. 1 minus x is 1 if x is 0. But here we want 1 minus x not equal to. That's why x is not equal to 0. So for these x values only, this function is defined first. Now, what are common values of this and this? Common value.
None.
I am talking about common values. Don't say whatever
2, 1, sir.
2, 1 interval not exist. Whenever you talk about interval,
Sir, is it null?
left hand side you must have a least value. See here, what this inequality says?
X
Greater
equal
All
to
x
that,
values
greater
are
than 2.
more than 2.
So 2 to infinity.
Wait, Rege. This
Empty
inequality says 2 to
This
infinity.
is common values.
This inequality says
Sir, is it minus infinity to infinity?
wait. All of you are going wrong. Just now I said to solve or to find intersection of two inequalities, better you take a real line and take the real numbers that are there in the two inequalities in the real line in ascending order. Then observe the common value.
Infinity to infinity.
There is no x which is greater than 2 as
Or
well
less
as
than
less than
1.
1. There is
And
no
this-
x satisfying both these two. So what we have is no value of x. No value of x satisfies. For no value of x, this logarithmic function not defined means no value of x, this inequality true.
Sir, can
If
you
the
once
function
explain
is
how,
not
sir?
defined, if the function is not defined for any x, so obviously that inequality is also not true for any x. So what is the solution set?
Empty set.
Empty set.
Empty set.
Sir, can you once explain how, sir? The last part I didn't understand.
Who is that, Ray?
Sir, me, sir.
Tell me your name.
Ujan.
Ujjan. Here, till this part, okay, na?
Yes, sir.
I want x values that satisfies this one and this one.
Yes, sir.
So the x values satisfying this are these. Greater than 2 means 2 to infinity.
Yes.
And x value satisfies this are this one. I want the common values of these two. Any common values there?
No, sir.
That's why no value of x satisfies.
Okay, sir.
So for any x, this is not defined means for any x, this inequality not true. That's why
Okay, sir.
solution set is an empty set. Okay, Navjan?
Yes, sir. Understood, sir.
Okay. Note down.
Sir, could you show the solution from first, sir?
Ma?
From first, sir, could you scroll up, sir, once?
You want solution for the first question?
Sir, this question, sir, from first I want, I told, sir.
This is the question.
Yes, sir.
Write one more. Log of x square minus 5 to the base 4 to the base 1 by 3 greater than 0. Log of x square minus 5. For this logarithmic function, this is the base. For this logarithmic function, this is the base. And for this logarithmic function, this is the variable. Log of x square minus 5 to the base 4. For this logarithmic function, this is the variable x square minus 5. Now see here. First two. When this is defined, listen carefully. This logarithmic function is defined if this variable is positive. That means log of x square minus 5 to the base 4 greater than 0. Then only this log of this thing is defined. Better you write like this. Log of x square minus 5 to the base 4 to the base 1 by 3 is defined. I'm not solving the inequality. First, I'm going to find x values that defines the logarithmic functions given in the equation. So when this logarithmic function is defined, if log of x square minus 5 to the base 4 greater than 0, that is x square minus 5 greater than 4 power 0. Definition. And base is more than 1, no change in the inequality. 4 power 0 is nothing but 1 only, na? That is x square minus 6 greater than. Tell me the factors of this quadratic.
Under root 6.
Minus plus
Amma?
6.
Tell me.
Sir, 6.
Minus and plus
Factors
6.
re
Under root 6.
x minus root 6 into x plus root 6. Is right?
Yes, sir.
6 can be written as root 6 whole square. Then use a square minus b square formula. A minus b into a plus b. And now using wavy curve, what are x values? Here minus root 6.
Minus root 6
Here
and
root 6.
root 6.
Plus minus plus. Now where is the x value that satisfies this inequality?
Minus
Minus infinity to minus
minus
root
root
6 and root 6 to
union
infinity.
root 6 to infinity.
Take it as 1 now. So this logarithmic function is defined for these x values. And one more logarithmic function is there, that is this one. Log of x square minus 5 to the base 4 is defined. What is the variable here? X square minus 5 greater than 0. Two logarithmic functions are there here. For this to define, for this total to define, this must be positive. From that we get these x values. And to define this logarithmic function, this must be positive. So it can be written as x minus root 5 into x plus root 5. That will give x belongs to minus infinity to minus root 5 union root 5 to infinity. Take it as 2. Now solve the inequality and get x values. That will give third equation. From 1 to 3, you have to find out the common values. What is the equation given actually? Log of x square minus 5 the
Sir,
base
what about
4 to the
1 by
base
3?
1 by 3 greater than 0. This is given. Now listen. First, I am going to eliminate this log by using the definition. So now it will be log of x square minus 5 to the base 4 less than 1 by 3 power 0. Log x to the base a greater than y implies x greater than a power y when base is less than 1. Here base is less than 1. That's why inequality sign reverse. Greater become less. I'm just using the definition. What is 1 by 3 power 0?
1.
1. Again apply the definition. Tell me what you get. Apply the definition. Tell me what you get.
X
Same
square
logarithm.
minus 5
Amma?
is greater.
Is
Amma?
great.
X square minus 5 is
Greater
greater
than
than
Y greater.
lesser than 4 power 1.
Lesser than 2.
Lesser than 4, sir.
Base is more than 1. It is increasing. That means whatever inequality, same we get.
Oh, same is
Depending upon base, you have to write every time. Previously, base is less than 1. That's a change. Here, base is more than 1. No change. From this, what you have? X square minus 9 less than 0. So it is x minus 3 into x plus 3. Less than 0. So use wavy curve. Minus 3, 3. Plus, minus, plus. Here we want the expression to be negative. So where you have negative values.
minus 3
3 to
and
3.
3.
3. Open.
Close.
Open brackets.
Because here less than 0 only given. Now tell me the intersection of 1, 2, 3. So for that, take a real line and get x values. What are x values we have? Minus root 6, minus root 5, root 6, minus 3, 3. Among all these 6 numbers, which is least? What are the real numbers we have? These two. Minus root 5, minus root 6, root 6. Which is least?
Minus root 6.
Minus 3. Minus 3.
Minus 3.
Minus 3 is least among all.
Yes, minus 3.
Next, minus root 6. Next, minus root 5. Next, root 5. Next, root 6. Next, 3. First inequality says the x values are less than minus root 6, greater than root 6. Second inequality says x values are less than minus root 5 and greater than root 5. Third inequality says x values are lie between minus 3 and 3. Now tell me, where we have all the 3 colors,
Minus 3 and 3.
all the 3 colors.
Minus
Here
9
we
and
have all
Minus
3
3 and
colors.
minus root 6 union root 6 comma
root
3.
6, comma 3.
All the 3 colors combination is there here and here. So finally, from 1, 2, 3, solution set is open minus 3 to minus root 6 union open root 6 to 3. Clear?
Yes, sir.
Writing common values. So first to define logarithmic functions, what are x values required? And then solve the inequality. Finally, take the common values of x values that defines the given logarithmic function, as well as the x values that are obtained from the
Sir, once can you repeat the solution set?
Common values. Here, three colors there na lines.
Yes, sir.
Black, red, green. Wherever all the three colors are there, that is the common portion. Here all three colors are there. Here all three colors are there. Here only two colors. Three colors there means that is the common values of three inequalities. 1, 2, 3.
Okay, sir. Okay, sir. Thanks.
Note down.
Sir, can you scroll down?
Sir, can you scroll down?
Sir, can you scroll down?
Sir, can you scroll upwards? Sir, can you scroll up?
Sir, can you scroll up? Sir, can you scroll down?
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 Greatest integer function. Sometimes we call this as a step function because its graph looks like steps. That's why we call it as a step function. Greatest integer function or step function. First listen, don't write anything. If x is any real number, then the greatest integer of x or step x denoted like this. Whenever you write x in square bracket, this is what this meaning is. It is integral part of x, or we can say it is the greatest integer less than or equal to x. X is any real number. Square bracket x is the greatest integer less than or equal to x, or it is integral part of x. You know, in any real number, say for example 3.4, this is a real number, no doubt in that. In this 3 is the integral part, that is the integer in that number, and the remaining 0.4 is there, that is called a fractional part. 3 is the integral part and 0.4 is the fractional part. So when x is 3.4, square bracket of 3.4 is 3. What is the meaning of the square bracket? Like modulus, we have this one. When you write anything inside the modulus, what it gives? The same sometimes, minus of that number sometimes. If 2 is there inside, outside the result is 2. If it is minus 2, outside we get 2 only. For this modulus, for this square bracket, whatever you write inside this, outside must be an integer. So what is integral part of 3.4? 3. Listen once again. I said here, this step x is integral part of x as well as greatest integer less than or equal to x. In this example, what is our x? 3.4. First tell me the integers that are less than or equal to 3.4. What are integers that are less than 3.4?
Minus infinity to 3.4 open.
3.3 also integer.
No, sir, 3.
Listen my question carefully. I'm asking the integers that are less than 3.4. You said minus infinity to 3.3 open. So this contains 2.5 also. Is it integer 2.5?
No.
How can you say this is minus infinity to 3.3? My question is, what are integers that are less than or equal to 3.4? 3, 2,
1.
1, 0, minus 1. These are all integers that are less than 3.4, na?
Yes.
Is it right or wrong?
Yes, sir.
Yes, sir.
Among all these integers which are less than 3.4, which is greatest?
3.
3.
3. So that's why we call it as the greatest integer less than or equal to x. It is less than x and this must be the greatest integer. First of all, it must be less than or equal to x and is greatest. So that's why integral part of 3.4 is 3 only. Tell me what is integral part of 3.1 now?
3.
3, sir. 3. Sir, 3.
Integral part of 3.9.
3.
3.
3.
So from the definition of integral part function or step function or greatest integer function, we have this conclusion, that is integral part of x is 0 if x value lies between 0 and 1. 0.1, 0.001, 0.3, 0.4, 0.5, 0.9999999. Its integral part is 0. And if x value lies between 1 and 2, what is integral part of x? Tell me.
1.
1 only. 1.1, 1.2, 1.3, 1.9999.
1.
See, observe here. I wrote a closed bracket this side and open bracket this side. What is integral part of 3?
3.
3 only. Here fractional part is 0. This is a real number. Its integral part is 3. Fractional part is 0. That means 3 can be written as 3.0. What is integral part of minus 2?
Minus 2.
Integral part of minus 2 is minus 2.
Minus 2.
Now we can define this integral part of x like this also. If x is any real number, lies between two integers, here n is an integer. If x is any real number and there exists an integer n such that x lies between n and n plus 1, then integral part of x is n. This is integer, this is also integer. If you take 3.4, what are integers in which 3.4 lies? Successive integers. 3 and 4, na?
3 and 4.
3.4 lies between two successive integers, 3 and 4. That's why integral part of 3.4 is 3. If a real number x lies between two consecutive integers, then integral part is the least integer. That is n. So any doubt in this definition?
No, sir.
No, sir.
Now tell me.
No, sir.
Integral part of integral part of minus 2.3.
Minus 2.
Minus 2.
No, minus 3. Minus 3.
Minus 3.
Minus 3. Minus 2.
So this is the real line. Listen. Here we have 0. Here we have minus 1. Here we have minus 2. Here we have minus 3. And here 1, 2, 3. First of all, where this minus 2.3? In the real line is between minus 2 to minus 3.
Minus 3 and minus 2.
Amma?
In minus
Here
3.
we
Well,
have
between
minus
-3 and -2.
So you write it as -2, then definition it fails. Why?
It should be
This
the
is
least
the
integer.
greatest integer that must be less than or equal to x. So -2 is not less than -2.3, it is more. So what is this value?
-3.
-3.
-3.
You have to write an integer before that, not after that. If you take 3.4, we are writing its integral part is 3, not 4. Na? Whatever real number given, for that real number, left side, whatever the integer is there, that is the integral part. So what is integral part of -3.4?
-4.
-4.
So integral part of -6.9.
-9.
-7.
-7. Huh?
Okay, na? Clear about definition of integral part function?
Yes, sir.
Yes, sir.
What is the domain of integral part of x? That means for what value of x it is defined? All values.
Negative.
All
All
real numbers.
values. All real numbers. If you take any real number, stuff x is defined. But what about the range? Output. Output you get integers only.
Only the set of integers.
Range of stuff x is z. Domain is R plus. Now write down the definition. Definition. The function denoted by fx is equal to square bracket x. From here onwards, I read it as step function, step x, or greatest integer of x, is called the greatest integer function is called the greatest integer function if this is equal to integral part of x, integral part of x, or greatest integer less than or equal to x. Or you can define this like this also. If x is any real number, if x is any real number and there exists integers n and n plus 1 such that n less than or equal to x less than n plus 1, then integral part of x is defined as n. Is defined as n. It is denoted by square bracket x. from the definition of integral part of x, we have integral part of x is equal to -2 if -2 less than or equal to x less than -1, and is -1 if x lies between -1 and 0, and is 0 if x lies between 0 and 1. Observe this. I am writing equality sign left side, not right side. If you write equality sign here, it will become 1. This is 1 if x lies between 1 and 2, and 2 if x lies between 2 and 3, and so on. And domain of integral part of x is R. Range of integral part of x is Z, integers. And coming to the graph, listen carefully. Graph of stuff x.
Sir, can you scroll up once? Sir, can you scroll into definition?
Wait, Ray. After explaining all the things, I will show from the beginning. Okay, na? See here. On x-axis, I am taking x values. And on y-axis, I am taking stuff x values. If x value lies between 0 and 1, if x value lies between 0 and 1, what is integral part of x value? 0 only. Here we have a gap, small gap. When it is 1, if the x value lies between 1 and 2, here, integral part of x is 1, so it's coming now here, this one. And at 2, it becomes 2. And 2 to 3, it is 2 only. Any doubt in drawing the graph? When x lies between 0 to 1, stuff x is 0 only. When x lies between 1 and 2, stuff x is 1. For all values lies between 1 and 2, it is 1 only. 1.1, 1.2, 1.3, 1.9. Similarly, between 2 to 3, it is 2. And coming this side, if it lies between -1 to 0, its integral part is -1. Here we have a gap. And it lies between -2 to -1. Its integral part is -2. Observe the graph. It looks like stuff.
10 minutes ఉంది 10:30 నుంచి బ్రేక్ లో ఛార్జింగ్ ఫుల్ పెట్టుకుని ఒక 10 minutes ఓకే ఎప్పుడు వస్తావు మళ్ళీ
అమ్మ మీరేమైనా పర్సనల్ గా మాట్లాడుకోవాలంటే మ్యూట్ చేసి మాట్లాడుకోండి తల్లి. ఎవరో పాప Clear about the graph of stuff x?
Yes, sir.
Yes, sir.
Why this greatest integer function is also called stuff function? Because the graph looks like stuffs. That's why. Now coming to the properties. Listen carefully. The first one, integral part of x always more than x minus 1 and is less than x. Definition itself says that it is the greatest integer less than or equal to x. That's why this value always less than x and is more than x minus 1. Suppose if you take x as 3.4, integral part of x is 3, na? That's why it is less than 3.4 and is more than 2.4. 3.4 minus 1 is 3.4. So integral part of x is less than or equal to x. When equal, if it is integer. If there is an integer 3, then equality holds. That's the first property. That's directly from the definition. And second, integral part of x plus y can be written as integral part of x plus integral part of y if at least one of them is an integer. One of them means either x or y or both. Then only we can write like this. Otherwise, you cannot write like this. See this. Integral part of 2.3 plus integral part of 3.7. 3.9. What is this value? Tell me. 2.3 plus 3.9.
5.
What is the sum of these two, Ray?
5.5.
5.2. What is integral part of 5.2?
5.
5.
6.
Sir, 6.2.
Sir, 6.2.
6.2, sir.
So what is integral part of 6.2? 6.
6.
What is integral part of 2.3?
2.
2.
Integral part of 3.9?
3.
What is their sum?
5.
5.
That means these two not equal, na? Integral part of x plus y is integral part of x plus integral part of y if this one or both integers. Here 2.3 is not integer, 3.9 not integer. That's why this equation not hold. If you take this is integer, for example 2. What is 2 plus 3.9?
5.9.
Its integral part is
5.
5. And see this part, integral part of 2 plus integral part of 3.9. This is 2 and this is 3. 5 only.
5.
So if either of these two is an integer or both integers, equality holds. Otherwise, equality not hold. Similarly, integral part of x plus n can be written as integral part of x plus n if n is an integer and x is any real number. If you want to separate n, from this step function, that is integer only possible. Otherwise, not possible. So you can write integral part of x plus 2 as integral part of x plus 2. But don't write integral part of x plus 2.3 as integral part of x plus 2. This is wrong. If this is integer, you can write separate. Whatever x it is. X is any real number, but n must be integer. And coming to the fourth property, this is very, very, very important. Integral part of x plus integral part of minus x is 0 if x is an integer and is minus 1 if x is not an integer. Integral part of x plus integral part of minus x 0 if x is an integer and minus 1 if x not an integer. See this. Let us take x is 2. Now what is integral part of 2 plus integral part of minus
2 and
2.
2 plus minus 2. Integral part of minus 2 is minus 2. It's not modulus. Integral part of -2 is -2. So 2 minus 2, 0. So let us take now x is 2.5. Sorry, 2.4. What is integral part of 2.4?
2,
2, sir.
Integral part of -2.4.
3,
Minus 3.
Now what is the sum?
1.
minus
Minus 1. Minus 1.
That's what I wrote. If x is integer, this sum is 0. If x is not an integer, this sum is -1. Integral part of x plus integral part of minus x is 0 if x is integer and is -1 if x is not an integer. What is, tell me, integral part of x? This is
X
integral part of x only,
X only, sir.
not x, integral part of
An
x.
integral part of X.
Suppose x is 2.3. Integral part of 2.3 and its integral part. Integral part of 2.3 is 2.
2,
2.
Integral part of 2
Integral
is
2.
2.
So this is same as this one. Simply integral part of x is x if x is integer. Here this is an integer. That's the integral part of that one will be the same. This is about greatest integer function. Now note down the definition, graph, domain, range, and properties.
Sir, can you move it a little bit left?
Sir, can you scroll down?
Sir, can you scroll down?
Sir, scroll down, sir.
So can you go a bit up, sir?
నేను ఆఫ్ చేసేసాను అప్పుడు
Sir, can you scroll up for a minute?
Okay, wait.
Done, sir.
Okay. Now listen. Coming to fractional part function.
Sir, can you scroll up once?